shift registers. Shift register is a device that is used to receive binary data and move them into position so that they can be utilized by other devices like example memory elements or adders. The most common memory element that is used in shift registers are the D-type latches. Now, shift registers can be divided into serial load or parallel load. This basically refers to how the shift register receives the data that it is moving through. The serial in serial input basically just means that each bit is introduced into the system one at a time, 1 bit per clock pulse. The parallel shift register or the parallel input basically means it receives all the bits at the same time, puts them in the positions that they need to be, and then it loads them or shifts them to the required positions. Now, for the serial in, serial out, SISO, we've got our D-type latches. Let's work on 4 bits. And we've got our data in at our Q. Then we've got our clock input, and these devices all need to be synchronized or synchronous in nature. As a result, all of them will receive the exact same clock pulse because we want them to function and operate at the same rate. Flip-flop 0 feeds its output into flip-flop 1. Flip-flop 1 feeds its output into flip-flop 2. Flip-flop 2 feeds its output into flip-flop 3. Sorry, that's D. And then that output will then go to another device. This one could be used to load data for transmission. This is flip-flop number 3. Now, looking at the system, let us accept that we want to move a binary string from the input through to the data output. So, with our clock pulse, basically what's going to happen is whatever information is presented on the input, when it receives the clock pulse, that information will move to the output of that memory element. So let's say we've got 1 on the input. That means that all of these are currently standing at 0. When I receive my first clock pulse, you can see that it runs on the negative edge. So when we get that negative edge, let's make that blue, sorry. When it receives that negative edge, this 0 is going to move into that position. This 0 is going to move into that position. That 0 is going to move into that position, and that 1 is going to move into that position. When we received another pulse, let's say we're introducing a 0 onto the system now, then that 0 is going to move to my data out. That 0 there is going to move to output of flip-flop 2. That 1 is going to move to the output of flip-flop 1, and then that 0 is going to move into the output of flip-flop 0. When we now, let's say, put a 1 on the input and we introduce our next clock pulse, what happens is this 0 moves to my data output, that 1 moves to my data or to my flip-flop 2's output there, that 0 moves to this output, and that 1 moves to that output over there. So we can see with each clock pulse that occurs, let's make that a 1 again. With each clock pulse that occurs, my data values move out to the next flip-flop's output. As a result, with each clock pulse, each bit is moved from one flip-flop to the next, and as a result, at the end, we will have all our bits move through our shift register.